So last time we've talked about some basic concepts on the Hedgehog Lab, and today I want to share more about the matrix manipulations in Hedgehog Lab. For example, you can initialize a matrix using a 2D array of number, which will initialize the matrix in this way, or you can also initialize the matrix using a 1D array of number, which will return a matrix 1 by n. And let's print a1 here, and you will see that a1 will be a 1 by 4 vector in this way. And also you can initialize the vector using a scalar or 1 by 1 matrix by passing a row number as the parameter, and you will see that it will be a 1 by 1 matrix with the value 1 in this way. So these are the three types of parameters that you can pass to the constructor. Another thing is you can initialize a matrix using a CSV format string. For example, we define a string, a raw string in JavaScript in CSV format 1, 2, 3, 4, and the output matrix of v will be 1, 2, 3, 4 in this way. So basically the function of CSV to mat will parse the string in CSV format and read and convert all the numbers into the corresponding element in the matrix. At least you need to guarantee that each column should have the same length and each row should have the same length. Also, there are a few functions that can help you to initialize matrix in MATLAB way. So if you are familiar with MATLAB, then you can initialize the I matrix, which is the diagonal matrix with all element equals to 1 by passing the length of the matrix. For example, you want to initialize the matrix 3 by 3, you can pass 3 to the I function and you will see the result here. Also, you can initialize a random matrix. Let me change it. Yes. If you want to initialize a random matrix 2 by 3, you can pass the first parameter as the number of row and second as number of column, and it's exactly the same as what you have in the MATLAB. So it will return a matrix with each element as a random number from 0 to 1, I think, a uniform distribution. Also, you can initialize a matrix of ones or zeros in this way. Another good thing is if you want to initialize a matrix by starting with the starting number and with an ending number, and with the step you can initialize in range. You can use the range function. For example, if you want to, let's try to print a vector from 1 to 20 with step 4, and let's see what's the result. So it will print 1, 5, 9, 13, 6, 17 with step 4, but it will never reach the ending number. So you can also use reshape member function to reshape the matrix in X rows and Y columns. It depends on the parameters you pass in. So if you reshape the matrix into 3 by 3 matrix, then it will automatically fill the element to the matrix and fill zeros at the end of the matrix if there are no enough elements. The next thing is the operator overloads. Yeah, you can see that here the tutorial 2 will it contains a few examples here. The first one is a plus b, a minus b, a multiplied by b, and a divided by b, which is this equals to a multiplied by b with power of -1. So usually you can use that to solve a group of linear equation. Also, you can use power of 3 in this way. Power of -1, which is the inverse of the matrix. Also, you can add a row to the array of number, or 1D array of number, as the right operand or the left operand. This can help you to this is the more straightforward way, that you don't have to initialize this matrix using the constructor or wrapper function. You can see that A plus is, you can see that the result will be still be valid. So this is the same as what you usually do on MATLAB. It's quite straightforward. If you're familiar with all the usage in MATLAB, then you can get familiar with all the usage very quickly. So here are some operators that the right operand is a raw number, so you can also do that, or you can do an element-wise multiplication by using double stars in this way. So it will multiply each element, corresponding element, and create a new matrix with the same shape. Or you can generate a matrix of element-wise power of n by using A star star and the power. Also, you can use the equal operator to compare two metrics. For example, we've shown this last time, but basically it's compared the L2 norm of the element from the left operand to the right operand. And this is an example of the matrix expression by you can see that it's very complicated. A transpose multiplied by B plus B multiplied by 4 minus A plus 1 multiply the inverse of B, and it will show the right result. So these are some basic operator and matrix